Yeah, hi guys, teacher Genevieve is back. This time to bring to your notice another science at your door. So now I want to show you the reason why that water being absorbed by paper towel, or the reason why paper towel is used in drying up water or wiping up water is because it has something to do with science. So today I want to show you the science behind paper towel water absorbency. Of course, absorbency means it can draw in water. We have absorbency, we have absorbency, the one that can bring out water. So paper towels absorb water because one, because of their cellulose fibers. This paper towel that you see here is made up of, the paper towel is made up of cellulose fibers. So they can draw water by two main methods. Either through that drawing, because they're made up of cellulose fibers, through these hydrogen bonds. They can take up water, and also they can draw water because they have tiny spaces in the fiber. There are tiny spaces in this paper towel. Can also help to draw up water through capillary action. Paper towels can absorb water because they are made up of cellulose fibers. And these cellulose fibers can hold water through hydrogen bonds. They can draw up water when you bring close contact water because they have tiny tubes, through spaces in the fiber that can draw water through capillary action. So before we go on, I want to explain what this hydrogen bonding is, because hydrogen bonding is very important, not only in this paper towel water absorbency. We will discuss a lot of things that this hydrogen bonding can do. So what is hydrogen bonding? People that study chemistry or that have some level of knowledge in science chemistry can understand, but I want to explain it in such a way that a layman can understand what it is. So hydrogen bonding is a special type of dipole attraction between molecules. I will explain. Science students can relate. And it results from the attractive force between a hydrogen atom covalently bonded to a very electronegative atoms, such as N is a symbol for nitrogen, O is symbol for oxygen, F is symbol for fluorine atom, and another very hydrogen bonding is a very important thing that we should know, because a lot of things that we are going to discuss during this our teachings, most of them are based on this hydrogen bonding. For instance, surface tension and other things. I said that hydrogen bonding is formed through covalent bonding between oxygen and hydrogen. If we look at the word oxygen, is an element that has 8 electrons. The atomic number of oxygen is 8, and the atomic number of hydrogen is 1 if you look at the periodic table. So because oxygen and hydrogen, they are all non-metals, they combine through electrovalent bonding. Covalent bonding. Covalent bonding. Covalent bonding is where electrons are shared, because they are non-metal. Non-metal do not donate electron. Instead, they are looking for electrons. So two of them are looking for electrons. What they will do is that they will share the electrons. So in formation of water, we have one oxygen. The outermost electron, we have 8. We have 2 inside. Let's forget about the one that's inside. Then nitrogen, we have 1 each. So during the bonding, they will share 2 electrons, because hydrogen has 1 each. So oxygen will bring 2 for it to share with the 2 hydrogen, forming water. But during this sharing, like I said before, electronegativity is ability of an atom to take more electron to itself when it's in a molecule. So the sharing is not always equal, because oxygen is more electronegative, that it has more electrons. It when during sharing, it tends to draw more electron to itself. So and when that thing happens, you look at the diagram, what will happen is that because the electrons are shifted, if you look at below, because the electrons are shifted, look at hydrogen, 2 hydrogen, during sharing is not equal, oxygen gets more electron. And because the sharing is in the direction of oxygen, electrons will be drawn to oxygen, leaving hydrogen with partial positive charge. It's not giving out all the electrons, but the sharing is electrons are shared, move towards the oxygen. Look at it. So at the end of the day, oxygen will be negatively charged because it has more electrons. Hydrogen will be positively charged. So because of this is what is known as that dipole attraction in a molecule. What is now hydrogen bonding, or formation of hydrogen bond? In a bucket of water, you have a lot of water molecules, and each water molecule, from what I've explained, because of this unequal sharing of electron, each water molecule will have a positive side of hydrogen and the negative side of oxygen. Then in that play where you have a lot of molecules of water, there's always tendency for the positive side of one water molecule to be attracted to the negative side of another water molecule. And look at, this is one water molecule. This is 1, 2, 3, 4, 5. If you look at the positive side, will always there's always a partial attraction between the positive and negative, positive and negative, positive and negative. And this partial attraction is what is known as hydrogen bonding. So in addition to normal bonding, you have the lines that are broken are hydrogen bonds, while the line that is thick is normal covalent bonding. So this hydrogen bond is very, very important phenomenon in chemistry or in science, and we apply it to a lot of other things that we are going to discuss. So in our next video, I will now show you how this hydrogen bonding or hydrogen bonds in a cellulose fiber, how it helps paper towel to absorb water. Thank you.